Good evening, dear students. Welcome back to second PUC online classes. Okay, in today's class, we're discussing about the de Broglie explanation of Bohr's second postulates. Okay, this one is the last class in this topic. Okay, from tomorrow onwards, we're discussing numerical problems based on the atoms chapter. De Broglie explanation of Bohr's second postulates. Dear students, already know the de Broglie wavelength equation lambda is equal to h divided by m into v. By using this one equation, we have to prove the derivation of a Bohr's quantization condition on the basis of a de Broglie wave theories. Okay, this one is a very important question for 3 marks. Question: obtain the Bohr's quantization, condition on the basis of de Broglie's theory. On the basis of de Broglie's theory. Okay, this one is the question. Here, one electron revolving around the nucleus in a circular orbit, its circumference of the orbit is considered as 2 pi r. For that number of orbit, that is considered as an n. Okay, according to de Broglie, an electron in its circular orbit must be seen as a particle wave, for an electron moving in the nth circular orbit of radius Rn with the speed Vn, then total distance traveled, traveled is equal to circumference of the orbit, circumference of the orbit. That circumference of the orbit is considered as an 2 pi Rn. This is a 2 pi Rn. Then For a permissible orbit, for a given orbit, for a permissible orbit, 2 pi r n is equal to n into lambda. This is equation number 1. Equation number 1. Then by using de Broglie wavelength, in the place of lambda we have to substitute h divided by m into v. Here n is equal to 1 2 3 dash 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 dash, like this. For a de Broglie wavelength is lambda is equal to h divided by m into v, in the place vn. This is a equation number 2. Now substituting equation 2 in equation 1, on substituting equation 2 in equation 1, we get okay, this one is a 2 pi r into n is equal to n into, in the place of lambda, h divided by mvn, mvn. Okay, mvn. Next you take this one vn this side, mvn this side, and 2 pi rn rhs side. After exchanging the two terms, we get mvn into rn is equal to nh divided by 2 pi. Here product of these three terms mvr, that is considered as an angular momentum. That angular momentum denoted by symbol L. L is equal to nh divided by 2 pi. This one is the final expression, okay, where L is equal to mvn rn. Okay, this one we call as angular momentum. L we call as angular momentum. This is the quantum condition. Proposed by Bohr's for angular momentum of an electron. Okay, this one is the 3 most important derivation, students. Practice this one. And last concept, that is the limitations of a Bohr's model or demerits of that Bohr's model. Okay, this one is also important for 3 marks. In a previous year, that is March 2014, in the year March 2014, this question will be asked for 3 marks. Question main heading, limitations of a Bohr's model. Limitations of a Bohr's model. First one limitation. This one is a March 2014 question. March 2014 for 3 marks. Question first one limitation. Bohr's theory is applicable only for simple atom like hydrogen atom. Okay, it is not applicable for complicated atoms, more than one electron atoms. Okay, this one is only applicable for the simple orbits like a hydrogen atom. Okay, and this theory fails to atoms for which jet greater than 1, atomic number greater than 1 atom. Okay, he failed to explain. First one, Bohr's theory. Bohr's theory is applicable only to simplest atom like hydrogen atom. This theory fails to atoms for which z greater than 1. This one is the first one limit. This theory applicable only for hydrogen atom. Hydrogen atom consists of only single electron. It is applicable only for the single electron atoms. It is not applicable for the more than one electron atoms. Second one, number 2, it could not explain the relative intensity of spectral lines. Relative intensity of spectral lines. Third one, sir, second one, it could not explain the relative intensity of spectral lines. Here different spectral is having different intensity. It could not explain the relative intensity of all the spectral lines. Third one, it could not explain the fine structure of spectral lines even in hydrogen atom. Fourth one, it could not explain the elliptical orbits of a electron. Okay, electron, this one is the fourth one. It could not explain the elliptical orbit of an hydrogen atom in an electron. It could not explain the elliptical orbit of an electron. Fifth one, it could not explain the wave nature of electron. Okay, these 5 are the limitations of Bohr's atomic model. Okay, for that 3 marks we have to write only 3 to 4 limitations, Up to here this topic over. From tomorrow onwards, we're discussing about the numerical problems related to the atoms. Thank you.